All right, so today's video is on 8.6, which is comparing functions. The reason we reviewed 3.7, which was absolute value functions, and 6.3, which was exponential functions, is because our goal of today is to determine what type of function I am modeling when you are given a graph table equation or real life situation. Okay. So this first chart we're going to fill in is going to help you know what type of function is what. And then the second page, we have some practice problems to work on together. Okay, so let's go ahead and get started. A linear function is in the form, wouldn't be right if I didn't start off by doing that, is in the form of y equals mx plus b, where m, remember, is your slope, and b is your y-intercept. The graph of a linear function is a straight line. And it must have a constant slope, or sometimes called a rate of change. And you can only use addition or subtraction if we're talking about a linear function, okay? So 5 to 7 is plus 2, 7 to 9 is plus 2, 9 to 11 is plus 2, and these are all plus 1, which means my slope here is 2 over 1, which is 2. So that is a constant slope, so this table is a linear function. Same thing over here, 5 to 3 is minus 2, and x is going up by 1 each time, so this is a slope of negative 2, so that is also a linear function. Oops. What the heck? Exponential functions. Exponential functions are in the form of y equals a times b to the x. Now, the most important thing to recognizing an exponential function is that x is in the exponent. Okay, that's your go-to sign that that is an equation is an exponential function. This is an exponential growth. Remember, you can also have an exponential decay. Decay looks like that, okay? But they kind of increase and then level off. The rule, you're looking for a constant change with multiplication. Okay, this is your b value that is changing. So 5 to 10 is times 2, 10 to 20 is times 2, 20 to 40 is times 2. Okay, now I know you're tempted to divide by 2 here, but you can only use multiplication, so this is all times 1/2. So if you're multiplying, that's an exponential function. Quadratic looks like y equals ax squared plus bx plus c. It can also look like x minus a and x minus b, because when you multiply those two x's together, you get x squared. Okay, so that's the two things quadratics could look like. I'm sure there's more, but those are two examples that I can think of right now. A quadratic graph is a U shape. And then this rule is a bit trickier. So 1 to 5 is plus 4, 5 to 17 is plus 12, 17 to 37 is plus 20, and 37 to 65 is plus 28. Now, I know those numbers don't make a whole lot of sense. So with quadratics, you have to go to the second change in y, because 4 to 12 is plus 8, 12 to 20 is plus 8, and so is 20 to 28. Okay, so when the second change in y is constant, meaning the same number, then it's a quadratic function. Let's try it again. 5 to 8 is plus 3, 8 to 9 is plus 1, 9 to 8 is minus 1, 8 to 5 is minus 3. So to get from 3 to 1, you had to subtract 2. To get from 1 to negative 1, you subtract 2. And to get from negative 1 to negative 3, you also subtract 2. So there's my second change in y is constant. Therefore, that is a quadratic function. Last one is an absolute value function. You can have an a out here. You can have some shifts within the a. But the main thing you're looking for are those absolute value bars. The absolute value bars make it so it's a V shape. Okay. And then the rule for absolute value tables is a little different as well. So let's start with our change in y. So we have -1, -1, +1, and +1. Now, there's nothing super constant there because we have two negative ones and two positive ones. Let's do the other one and see if we see a pattern. So -3 to -1 is +2, and then we have -2. Okay, so a lot of you are going to see this. You're going to want to do a second change in y, just like we had to do up with quadratics, but you actually don't have to do that, okay? Because with absolute value, all four of these numbers need to be the same. Two of them need to be positive, and two of them need to be negative, okay? So I have two negative ones and two positive ones. I have two positive twos and two negative twos. It doesn't matter which one comes first, okay? So you need to have the same numbers, and with that, you need two positive and two negative, okay? If you look up here, we have +3, +1, -1, -3. A lot of people get mixed up and think this is absolute value because it has two positives and two negatives. But remember, these numbers are all not the same. Therefore, that one's a quadratic, and these are absolute value, okay? All about the patterns. Now let's look at some examples and tell what type of functions they are. So I'll allow you to be lazy. We can write L for linear, exponential, either one an exponential growth or an exponential decay. Absolute value, we can put AV, Q for quadratic, okay? X is in the exponent for number 1, so this is exponential. Since that is bigger than 1, this is an exponential growth. X squared, I know that's a quadratic. If you need to put a +0 there to make it look like standard form, go ahead. Number 3 is in the form of y equals mx plus b. So this is a linear function for number 3. Number 4, y equals 7 is a horizontal line at 7. And a horizontal line is a linear function. I really hope you just heard my dog sigh in that background. Number 5, those are absolute value bars. So number 5 is an absolute value function. And then number 6, here's that x times x thing that I was talking about. That'll give us x squared, which is a quadratic. Looking at the graphs should be pretty easy. 7 is absolute value. 8's a straight line, so that's linear. 9 is exponential. Reading from left to right, it's going down, so that's an exponential decay. Number 10 is a quadratic. The reason it's upside down is because it's being reflected. That's good to know. 11 is a horizontal line, so that is a linear function. 12 is a vertical line, tricky, which is none of the above. A vertical line is not a function. Each input has more than one output that is the same, so that doesn't work. All right, 13 and 14. I'm going to hit pause because you don't need to watch me plot points. And I want you to plot the points in 13 and 14, and then come back and we'll talk about which function they are. All right, so I plotted the points on 13 and 14. 14 is pretty obvious. This is shaped like this, so this is an exponential decay because it's reading from left to right, it's going down, okay? 13 is not so obvious. It's either absolute value or it's a quadratic. And how do you know what is what? Okay, and the easiest way I can tell you to do this is to make a table. Now this is kind of tricky because these points aren't in order. So you need to write this one first. This pattern thing doesn't work unless you write the points in order. So -5, 8, -4, 4, -3, 2, -2, 4, and -1, 8. Okay? Once you write your x values in order with their corresponding y values, then you can do your table magic. So 8 to 4 is -4, 4 to 2 is -2, 2 to 4 is +2, 4 to 8 is +4. So since these numbers are not the same, you know that this is going to be a U shape and not a V shape. Okay, so this is a quadratic function, not an absolute value function. So sometimes even the points aren't enough to be specific in your picture. All right, let's look at the tables. 4 to 1, -3, -3, -3, minus 3. This is a linear function. 16, 9 to 6 is minus 3, 6 to 5 minus 1, 5 to 6 plus 1, and 6 to 9 is plus 3. Different numbers, 2 positive, 2 negative, so we need to keep going. So this is plus 2, plus 2, plus 2. So since the second change in y is constant, this is a quadratic function. Let's look at 17. Negative 1 to 1 is plus 2. 1 to 3 is plus 2. 3 to 1 is minus 2. 1 to negative 1 is minus 2. So I have 2 positives, 2 negatives. All 4 numbers are 2, so this is an absolute value function. And 18, 20, 10, 5, I'm cutting these in half. Remember, you must use multiplication. You can't use division or it won't work. So since we're cutting it in half, this is an exponential decay. A couple more word problems. Here we go. A ball was thrown in the air from a height of 5 feet. What type of function is this? Well, here's my ball. It was thrown in the air. It's eventually going to hit the ground. We did a lot of word problems like this in chapter 7. So this is a quadratic function. Your friends can type 85 words per minute. That is a slope. Okay, and when you have a constant slope, it's a linear function. And the membership of a club doubles every year. That's times 2. So that's exponential growth. The company's membership is going to grow exponentially if it's doubling each year. That's it for notes. There is a corresponding practice page in your homework packet that you can be working on. And I will check back in with you tomorrow.